We're going to write an equation for the graph in factored form. The first thing I notice is this is an odd degree because one end is pointed down and one up. So I know I have to have an odd number of factors. The factors will be made up of these zeros or x-intercepts. We can see that the graph touches the x-axis at -2, 1, 2, 3, and 4. Each of those will make a factor. Those are the numbers that will make it equal 0. X plus 2, because -2 makes that equal 0. X minus 1, and x minus 4. I have 3 factors. There are 3 zeros, and each of the zeros is a factor, or is represented by a factor. Because this graph goes from left to right, going up, it eventually goes up, this is a positive. You don't need to put anything in front when it's positive. To make it a function or an equation, we put y equals, or sometimes use f of x equals, depending on the question. Make sure to read the instructions to know whether it states you need to use y equals or f of x equals. It's an odd degree. We can see that there are three factors and there are 3 zeros. Okay, let's try one that is an even degree. This one has an even degree. Let's see. This crosses at -3 or touches at -3, 4, and 7. When we have a graph that bounces on the x-axis, as we can see that happens here at -3, a bounce will be a double root. That one will get an exponent of 2. When it crosses smoothly, it's a single root. So this factor will be x plus 3 squared, because it bounces. A bounce will be a double root. X minus 4 and x minus 7. This one has a degree of 4. If you add up those exponents, 1 plus 1 plus 2 is 4. There are 4 zeros. There are 4 factors. Sometimes we put y equals, sometimes we put f of x equals. Make sure to read the instructions to know which. Now, because both ends are pointed down, this is a negative polynomial. The leading coefficient will be negative because both ends are pointed down. Now, if both ends are pointed up, it'd be positive.